Hi, let's take a look at the first assignment in COIS/FRSC 2750H. Once you've done this, you should post your assignment in the appropriate Dropbox on Blackboard. It is important before you submit it to check to make sure that we can actually read the file. If we can't read it, we can give you marks for it. Please use either PDF or doc formats if it's at all possible. The assignment is due by the end of the day, June the 1st. So question number 1 is just a simple one. Just use your binary to hex conversion chart to do the following. And the last couple parts of the first question deal with adding hexadecimal numbers. Again, if you follow the clip, it should be fine to do this. Question number 2, we're going to use our ASCII chart to convert or to find the binary digits or the hex digits that represent the following words. Part A is forensics and the headache. No chance. Be sure that you include the hex digits for the space between no and chance. And then the last part, what is the text message represented by the following hex digits? So just use your ASCII chart to determine what letters that are being represented by these hex digits. Question number 3 is one of our encryption questions, and it's a Caesar cipher, a complex Caesar cipher. So let's assume that we use the same baseline as we did in the example, so A to Z, a space, and then 0 to 9. We're also going to use Trudy Jones for a code phrase to tell us what the code is, what the key is for deciphering the message. So just like in the example, if the first two pairs happen to be UY and DU, the code then is 24 and 32, which means first to encode it, we take the first two letters 4 places to the right, the next 3 letters 2 places to the left, and then repeat that until we run out of letters. Keep in mind that to decode it, we have to move the opposite direction, so the first 2 letters would go 4 places to the left, and the next 3, 2 places to the right. So the question is, what is the message hidden in this phrase? So we need to look at UD and YU to see what the key is, and once we've got the key, we should be able to decipher this message. This message actually describes a fictional character. If you don't know the name of this fictional character, just look it up on Google and you should be able to find the name of this person, and then just encrypt this person's name using the same scheme as in the original message. Question number 4 looks at computer encryption. The algorithm that we're going to use is to rotate the bits of the message 4 spots to the right, then XOR the bits with the key, and then rotate the bits 8 positions to the left. So how do we find the key? Well, I'm going to email it to you, hidden within a spam message. This is an example of steganography. So you will receive the message. You should cut and paste the body of the email on your computer, then go to the given URL, click on decode, paste in the message, and you'll get the key back. Once you've got the key, use that to decrypt the following name. Again, remember you have to reverse the order and direction of operations to decrypt the name. So as an example, we'd start by rotating 8 spots to the right, and then XOR, and then rotate to the left. So the answer is actually the name of a Norse god. So I want you to find the name of his wife. Again, you can use Google to find that, and encrypt the name. When you encrypt the name, I want you to use the following format: the first letter in uppercase and the following letters in lowercase, like the example given, Bonnie. And Bonnie is not the name of the Norse god. So question number 5. One problem that an encryption system can have is if we never allow the encrypted value of a letter to be the same as the original. especially if a letter always encodes to the same value. So we're going to see how we can use this. So let's assume that we've intercepted a message, and we know that my last name is in there, Hercog. So using the fact that we know that letters always encode to the same, we can actually find the encrypted values of the letters in my name, H-I-R-C-O-N-K. After you've done that, you can test your detective skills to tell me what the original message is. Now, when you try to do this, you're going to have to take my name, the H-I-R-C-O-C-K, start mapping that to the first first 7 letters. And what you're looking for is if any letter is the same, then that's not a possibility. And you notice in my name there's 2 C's. So those 2 C's would have to encode to the same value. So you're going to check the 7 letters to see whether or not any are the same, and to check to make sure that the 2 C's are encoded as the same thing. If the first 7 letters don't match, and they don't, then you'll have to keep sliding along until you do find 7 letters that do match, and there is a set of letters that do that. Once you've got that, you can try to fill in any missing letters. You can also try to figure out what this encoding system is. It's a very simple Caesar cipher, actually. Once you've done that, then you should be able to come up with the original message. Again, if you have any problems, send me an email or call me during my office hours. And have fun.